Good. All right, so look, you can't go too far these days without seeing a headline around the pressure AI is putting on power. Our power systems, our energy systems. Jensen himself is saying there's no AI without power, your revenue is limited if you don't have power. But what are we doing about it? How often are you hearing, here is a way forward, here is something that's going to get us through this AI era? Cisco puts out an AI readiness survey, and across our entire portfolio, our customers are saying, we are going to spend a lot of money in AI, but very few of them know exactly how, where, and what to navigate. So we're starting to see this theme. There's a lot to do, there's a lot of investment coming, but we're not quite sure where to go or how to navigate this. Help. At the end of last year, I had the opportunity, by sheer coincidence, it was not planned this way, but I ended up on a world tour. And this world tour was not just about customers and conferences. It actually had to do with government, academia, industries. And over the course of 7 weeks across 4 continents, I heard from all these different sectors moving at unprecedented speed, trying to produce change that we have never seen in this generation. So I want you to think about how much has changed in your worlds in this last 12 months, 18 months. 2 years since ChatGPT came out in 22, or a couple years since ChatGPT came out in 22, and in 2 weeks hit 10 million users. Over the last couple of years, we've been building out these ecosystems of partners, right? If you've seen me here at Cisco Live or another Cisco Live event, in the past, you might have heard me or seen me on stage as Engineering Sustainability Office. And what we were doing is we were cultivating groups of partners and technology vendors to build an ecosystem of where and how are we going to work together to build products that will be better integrated, interoperable, more open standards. We've actually worked with some of these partners to stand up a third-party testing certification lab so that we can put together solutions that are easier for customers to just go and deploy. What's interesting about this is this is not your typical, let's go validate this in some of our labs. Some of these designs in these use cases, and these use cases are many across Cisco's entire architecture, both on the data center side and in the campus and the workplace side. So whether you're talking about smart lighting or liquid cooling, some of these architecture designs are actually going into the facilities, the real estate, MEP firms. This is different than what we've done in our past because these ecosystems are growing. And part of the reason they're growing, and part of the reason we're working on developing across the entire portfolio, you would have heard again and again, Cisco's got these 3 key areas that we're focusing on, from AI-ready data centers to future-proof workspaces and digital resilience. My team has the opportunity and privilege to work across our entire portfolio, across our entire partner ecosystem, to figure out how exactly are we going to move the needle across Cisco's entire portfolio. 4 years ago, we started with the basics, data. How and where do we standardize on data? And with the partnership across many functions in our organization, we put together a sustainable data foundation, and we standardized on 5 key energy metrics that you see here. With these 5 key metrics standardized and offered visibility for free across the majority of Cisco's endpoints, many of our customers and partners don't even know this is available or exists. Some partners do, and are putting together services and new offerings because in this world where we don't have enough power where we need it when we need it, this data allows you to figure out how to further monetize and help customers on this journey to more resilient energy. But you'll also know, and if you've followed on this journey at all, the evolution of Engineering Sustainability Office into energy networking systems is all predicated on one key core technology that is new. How many of you have heard of fault managed power? Great. For those who have not, I want you to think about where you're sitting at this moment what you're doing here at this conference, and I want you to take note that you're about to hear of a revolutionary technology that I hope you hear about for the rest of your life. Back in the time when Edison and Tesla were debating between AC and DC, it was Edison who said there should be no reason that we have AC power. The same engineers who helped us bring power over Ethernet to market 25 years ago were asked 8 years ago, what comes after PoE? Because at 100 watts, it tops out. And even 8 years ago, they said, by 2025, we're going to need something more. What that something more is, and what that new technology is a brand new class of power for the first time in 45 years called Class 4 fault managed power. What is it? It's pulsed power, and there's 3 components to it. There's a transmitter, a cable, and a receiver. And this pulsed power is touch safe, high voltage, up to 450 volt DC. Raise your hand if you've ever touched 380 volt DC. The fact that you're raising your hand and not dead means you know about this technology. When I first learned about this 4 years ago, talking to one of our Cisco engineering fellows, I immediately called my 5 most technical friends. I said, rip off your COVID mask, come into this lab, and tell me I'm not crazy, because I'm about to pivot my entire career to bring this to market, if this is in fact real. Because my head was spinning with all of the different use cases of what you could do with touch-safe, high-voltage power. From EV cars, to homes, to offices. And then AI decided to, boom, and there's not enough energy where you need it. So it's so exciting. We had this foundation of energy management so we could measure where the energy is with more accuracy. We could use the intelligence of the network to do so. And now we're going to add power to those same cables and same lines that we have been safely and securely networking data for the past 40 years. What other company is better positioned to do that? So you might ask, how does this fit into my network? What does this mean, right? So I mentioned the transmitter, the cables, the receiver. So effectively, and you may or may not be paying attention, but over the last number of years, we've been shipping 380 volt DC power supplies with the majority of our new appliances. 380 volt DC is an ecosystem that already exists. You need certified electricians. It's a little dangerous, but those things do exist. So when these FMP transmitters get connected to appliance, whether that's a Cisco appliance, an HVAC system, eventually a car, you can even do side-by-side with fiber and copper. These are different use cases that we're seeing just to start. But when you look at all of the challenges across retooling the data centers, well, remember, we said energy networking systems. 4 years ago, we also started with cooling. And we said, what are the ecosystem partners we need to work with for these cooling systems? Because in a data center, 40–50% of that energy is going to cooling. It's going to fans. That's wasted energy. So we actually don't necessarily need, if you go talk to some of the utilities, they'll tell you, we don't have an energy generation problem. We have an energy loss distribution problem. We can't get energy where you need it when you need it because we have a forecast demand response problem. And so as we're building this AI-ready data center, we have to now think about moving workloads and how to power those workloads and maybe turn them off and down, up and down at the right time. We have to think about how we secure every stack in an AI-ready data center. And we have to think about how we're going to integrate this with all of the new cooling technologies and architectures that are out there. And there are a lot. In the last 4 years, it has been so much fun incubating and prototyping new devices and products. And for the first time, one of our prototypes has now been announced on stage, right? What's now the 106.1, my brain is jet lagged, switch is direct liquid cooled. So there's a Nexus switch, and then there's a router series. And this switch is now direct to chip liquid cooled. We started with the 512T. We skipped a generation and said, let's go for the next one. But that prototype started with this thinking and this team of integrating all these things together. Immersion, same thing. We've been bringing this immersion tank around the world. We don't produce an immersion tank. We don't manufacture oil, right? We don't refine oil. That's not Cisco's core business. But you better believe we're going to work with those in the industry, curate them, and put together and test what components will work together for these solutions. And so when you think about in a data center, there's actually a number of different IT and OT things that are coming together very quickly beyond just energy networking. Now you have to look at the facility, the envelope. How many new data centers are we hearing about every day being built? Gartner has a recent study saying 40% of the data centers that are being planned will hit delays because of power constraints. Anyone want to guess how long it takes to bring up a data center to grid connectivity? Obviously, it varies by region, but we're talking grid connectivity. It can be as few as 3 years in some places. Here where we are today in Amsterdam, it's 10 to 13 years. So imagine building an entire data center realizing you don't actually have enough power to turn it on, and how much the technology is going to advance and mature in that time. When you look at the data center, you have to unpack all of these different spaces. What's considered sort of that white space or this gray space with mechanical, plumbing, and electrical, or the blue space, water, how much water existing data centers are taking with all the air-cooled chillers and all the chilled water that has to run through facilities. But then just think of the facility itself and how many sensors and cameras and Wi-Fi are just running the building operations. There's an opportunity here to take power distribution to a completely different level. In a data center, just think about how many copper bus bars you're putting in there for these rack densities that are going up, up, and up. And when we look at the rack, we're looking at all these different layers. Traditionally, customers are looking at Cisco at layer 10. This is respect to supply chain layers. But now we're looking at integration in the rack at layer 11 and layer 12. These numbers are directionally correct, but take a look at what happens to the liquid cooling architectures when you look at the legacy air-cooled data centers, which are typically like 10 kilowatts a rack. All of a sudden, we're going to, how about 30? How about 50? How about 150? At OCP a couple months ago, there was like, this is a megawatt rack. Anyone in the audience super excited to service a megawatt rack? With today's technology, I'm not sure that's not, I mean, not only is that not safe, I don't know how feasible that is, right? With just this amount of labor and electricians you're going to need to build these things, the amount of precious metal you're going to need. So then you start pushing the limits with direct liquid cooling. Direct to chip is fantastic. Right? You get much farther, you can go 150, a little bit more, especially if you add a rear door heat exchanger. But if you've ever connected one of those or seen one of those in practice, it's a lot of hoses, it's a lot of pumps, it's a lot of fluid. But it's in a rack. It's comfortable for people who like the rack design. If you go see an entire data center with immersion cooling, it's silent, there are no moving parts, and it's not, you don't have to cool it. So it's not, you don't have hot and cold aisles like you do in a data center. So I think what's interesting about the technology space and new innovation is you're going to start to see, if you keep that open mind, different use cases for different environments, different industries will necessitate a different architecture. And if you build things or retrofit things built for those use cases, that's an efficiency story. So when you consider rear door heat exchanger, maybe combine it with direct liquid cooling because you're retrofitting an existing data center. But if you're building a brand new data center, I really hope you're not building it on raised floors with a bunch of air-chilled coolers on the ceiling or on the roof, right? There's a lot of different things that you would consider for a brand new data center. And this is where energy management, again, at the base level of understanding where your energy is going and how much you're using, let's make sure that energy is not wasted. Every year when we come to these events, I want to make sure that we're moving the needle forward. This year, that needle forward is we have taken Cisco Unified Edge, which was just announced at Partner Summit, and we have fully immersed it in a tank on the show floor. It's a prototype. But if you're in a rough environment, if you are in a manufacturing environment, if you have mining and you understand what a speck of dust can do to a power supply or to your very expensive equipment, or you're looking at inferencing and you want to move things further and further out to the edge for edge computing, imagine what you could do if you take this 5RU rack, stick it in a little tank, seal it, set and forget it. So this is a prototype. We want your feedback. Is this something that would be useful? Is this something that you'd want us to prioritize? Because that's the beauty of the pace of change things are happening. We get your feedback at these shows, and this time next year, we hopefully see it on a roadmap. When we look at the benefits of liquid cooling, it doesn't take a scientist or a physics major to understand liquid cooling is far superior. I think what's really challenging is what architecture, what vendors are you using, and how do you make sure it works? Because I've seen what happens when a pump breaks or a hose comes loose. It's not so pretty. So how are you building these architectures, and what use cases and what redundancies do you have for all of your data? And what applications are you running on those things? Working with customers across all of these different industries, I can tell you the more sophisticated ones are building each architecture based on the applications the systems are running. It gets more and more sophisticated. I often get asked the question, well, show me the numbers. What's the ROI? What's the TCO on this? If you take an air-cooled data center today, about a 5 megawatt data center, and you apply direct liquid cooling, and you apply what benefits you would get from the power distribution from fault-managed power, you're saving about 76% of your energy costs, which equates to 2.3 times the amount of compute you would otherwise use. Just to help you understand what this looks like or what this means, I think a lot of people don't quite understand the math that is wasted power and energy in data centers today. So you ask for more power, it's like you're already paying for the power, why not just get more out of it? It's an efficiency question. And when you take this and you move over to the campus, right, let's switch gears for a moment. Smart buildings have been around for a long time. That's not new terminology for any of us. Hopefully, like raise your hand if you've been in an environment that would be, LEED, gold, or platinum certified. It feels like a smart building, right? Hopefully you realize it feels better, you might be more productive. But when you think about how to modernize that real estate and what it takes to get that outcome for an experience for someone, it's data-driven analytics. It's that convergence of IT/OT. It's connecting all the things. And then it improves that experience. So think about, again, where F&P can potentially sit in this ecosystem. You often need lots of steel conduit for electrical in every smart building. You often need a lot of downtime, to retrofit a building. This technology will take out time, cost, and your time to market, because you don't need to shut down as long because it's much faster to install. So when I think about all the use cases that we think about for smart buildings as being like, that's really cool. Well, what if you could do it faster, safer, and cheaper? It's effectively what we're talking about with this new technology. And then think about the ecosystem. So we have partners here at the show in the booth with fault-managed power, and this story has continued to build on itself. I think it was 2 years ago at this show when we first started introducing what fault-managed power is. Now we have an entire demo, and we have a partner ecosystem to show all the PoE devices. And partnering with Panduit, we've brought you a FMP transmitter that is UL certified. So yes, there are building codes. Yes, there are still hurdles and standards that we are working on across the board. But remember, when I said I went back to that world tour of industry groups and standards, there is an acknowledgement today that was not there even 12 months ago that things have to change. And these things have to change at legacy levels that you may never have thought would need to change, whether it's your electrical code or your building codes. Now everyone is thinking, we cannot build the same way we have in the past. And I have seen that and witnessed that at every level, even at the academia level, where they're changing curriculum mid-course to get graduates ready for what's coming. So you look at a basic building and all the conduit that goes in, the red, the green, the orange. There's a lot that goes into all the different types of cabling practices and all the materials. When you go to fault managed power, you might have AC into the building, and then the minute you go into that fault managed power transmitter, everything is DC from there on. Same thing would work in a data center. This just happens to be more mature because PoE's been around for 25 years, and the entire ecosystem for lighting, LED lighting, blinds, desks, individual fans are all there for a building. And there are smart buildings that continue to go up around the world. And it's pretty fascinating to see what that ROI looks like for the different developers and the operators. And when you look in the campus at the efficiency fault managed power will bring, I want you to think about the last time you walked into a retrofit of a building or a brand new building build and how much time and cost would be saved if the cabling practices were as easy as installing power over Ethernet. And what you could do with the intelligence of all the data coming in through the appliances, through a switch, and every endpoint. And the savings, just to give some more numbers and example, are remarkable. Panduit is a great partner of ours. They have an FMP transmitter in market today. And what they saw in a recent deployment, these are real numbers, is 20% CapEx savings, because while they were spending more on material, the labor cost and the time was so much less, it was 22% savings. The ongoing maintenance costs in terms of both energy efficiency and the maintenance costs for the systems, 78% annually. This ROI TCO takes care of itself. And so when I consider all the change, and for those who are hearing about fault managed power for the first time, I hope seeing is believing, because we have an entire demo powered by fault managed power just behind you. I hope you realize, okay, well, what does this look like maybe for my own customers or own environments? Again, for the first time, we bring you a brand new project that we're kicking off for the next 9 months. We're kicking off getting these kits for pilots and proof of concepts in customer environments. So our strategic accounts, people are raising their hands all over the world, whether it's academic institutions, labs, manufacturing facilities, those who are just curious. One of the things that's really fun about this job is getting this new technology into someone's hands who actually understand how revolutionary this technology is. And then a small pallet drops on their driveway or at their loading dock, and like a kid with a brand new set of Legos, they get to install it themselves. And they get to say, hey, I want this to plug right into my Catalyst 900 that's already powering this entire conference room. Or I'm going to do this lab environment. Or I'm going to test it out for these racks. We're seeing a lot of customers now say, let's go. And when I consider how much change has happened over the last 18 months even, and even what's going to happen in the next 12 months, I want you to think about what your role is to play in that. Out of curiosity, how many people here know who runs the facilities or real estate in their organization? One. Okay. So for those who didn't raise their hand, I would highly encourage you to go get to know those folks. Take them to coffee, a drink, lunch, and ask the question, what happens if we retrofit using brand new power distribution that is efficient, easy to install, and cheaper to maintain? When we talk about what's going on in the future with energy, one trend is very clear. Distributed energy systems. On-site generation. There's solar on so many of the roofs that wherever I travel, I see more and more solar on roofs. Well, guess what? Solar is DC native. So if you want DC microgrid, if you want more resilience in whatever facility you might be operating, you're going to want to know those facility folks. And they're going to want to know you. Because when you combine energy and networking, now you have the power and intelligence to manage that. And facilities budget tends to be longer outlook, and at least double, if not triple or quadruple, the budgets of IT. And so we're working across a broad ecosystem of partners, new partners, because they're raising their hands saying, we need help. Help us navigate the architectures, the designs, and the systems. Help us build this into the plans because the investment dollars are there and the change is coming, but we need your help. And when I think about the last couple of years pushing thought leadership and pushing and educating, the one thing I would ask all of you as you go through the show is how many things have you seen that are genuinely new technology, new innovation? Incremental is great, don't get me wrong, we need efficiency everywhere, and there are really neat, innovative ways to get there. But every once in a while, you get a chance to work on something that is truly revolutionary. The Cisco engineering fellow behind this often tells me, Denise, this has changed the world stuff. And the fact that he's got an entire career dedicated to patents, we've just closing in on 100 patents on this technology, and watching build Cisco's chassis from 20, 30 years ago, for him to say that carries weight that is hard to come by. And so I invite all of you to come on this journey with us. We are just getting started. It's going to be a lot of fun. We're going to learn a lot together. And I hope you have a chance over the next couple of days to see it, learn more, and maybe take one home. Thanks.